turning this into this. Now, my methods for fabrication are definitely outside the box. I do not weld anything rolled, I do everything in position, such as my matey over here. Everything is welded in position. It's definitely more awkward, but to be able to fabricate everything, get everything all done, it's well worth it. This is a 10-inch TruBore piece of stainless. TruBore meaning the thickness of it is like 2 point something mil thick, 2.4. It requires one run to do the root and the cap. So these are the taff ends, the collars, the flanges, T, elbow pipes. I'm going to be welding it with either 1.6 mil or 2.4 mil, I believe it is, on a Miller Maxstar 210 with about 86 amps, and on the taps I'll go about 95 amps on the taps. Shielding gas is argon and nitrogen. Welcome back everyone. It has been a while since my last video. Apologies for the delay. There really isn't no excuses other than laziness and life, but we are back, so let's enjoy it. In this video I am going to try to be as informative as possible without going on random tangents about anything. So I'm gonna stick to topic the whole way through, starting with this blunt drill bit. I've tried so many different methods to drilling these holes. Originally we would use plasma cutters, but they was just leaving a whole bunch of nasty contamination in the pipe, and it was a lot longer plasma cutting, die grinding and cleaning. So we moved over to drilling holes, and originally I was using my Fine sponsored drill bits. They're the tool sponsor for my channel, and yeah, they were my personal ones, and I was just going through them because I'm doing hundreds of holes. So we moved over to hole maker drill bits, but they was removing too much material. Just on carbon I'm sure they're good, but with this stainless it was so much more harder, and it's trying to remove a 2-3 mil thickness of material to drill the hole. Then finally we found the Starrett, I think they are something, you'll know what I'm talking about if you've ever seen them. So far they're a lot cheaper, they're turning into like a consumable, but it's definitely better than using the plasma cutter, and would definitely recommend it. For you lot, you've probably already been using them, but hey, places that I've been, it took a long time to move over to drilling holes and not using the plasma cutter. Anyway, back onto tacking the taff together. The hardest part of working with TruBore is just the tolerances of all the pipes. Nothing is the same size. Nothing's a circle shape. Everything is just a headache. The taffs, I believe, have a 2% tolerance to the size of the pipe. So when I hang my taffs, I don't even try to make the inside flush. I make the outside a mil and a half higher than the pipe, and then try to chase it all the way around. Sometimes it works, sometimes it don't work, but yeah, many times I am welding with my high-low literally being the bottom of the taff is at the top of the pipe. That's how crazy the high-low gets sometimes. Yeah, I'm doing some craziness now to try hang this elbow. Working alone, it's what happens. Being on price work, working alone, you ain't got the privilege of having a helper. But what you do have is a decent wage. So being on price work, yeah, you just try to rush and make do. What you see me using was a homemade DIY clamp. It's basically this 10-inch pipe cut into a sliver, holes marked and drilled in it so you can tack your pipes together. It's really DIY, but it does the job. It does the job. Otherwise, you know, you put one tack on it and you have to try to chase around the pipe, add in a piece there for leverage to, you know, push the high-lows. It's long. So I post almost every day onto my Instagram channel, and a lot of the comments ask, why do I tack everything together and weld everything in one go? Why don't I roll out the taffs and roll this out and join it on? And I say speed.
speed really. You're going to see in this video here, I roll this out and then I attach it to the rest of the pipe, and then I basically double handled, and I didn't have any additional speed. I just wanted to kind of show the other side of things.
So I changed my mind. It's purging now. I used this opportunity to give it a little clean up with the wire wheel. I'm gonna put tape around it. Nice little branch to do, or socket I should say. But yeah, this is my quick release purging gear. Got a bung in the end over here. Just purging away right now. The tap, I'll turn my upslope up. The tap I would do 92 amps, probably 1.6 wire. If I do 2.4, you get more routing, but the material just gets too hot because you're melting so much stuff. It just gets hot for some reason and starts to go discolored. I'll try this.
So I'm welding this socket at quite a high amps. It's 92, around anywhere from 86 to around 90, 97 amps. I like to run. Even on 4-inch, I do 90 amps on 4-inch, and you may think it's so crazy high, and it is done incorrectly. But as long as you keep moving, do not stand still, keep moving, have high gas flow, keep dabbing wire. No matter how slow or much of a brain fart you might be having, the material's still getting hot and wire still needs to be getting dabbed in. So you need to just make sure you are on point and keep that wire going in there and keep that movement no matter what happens. And then you can get away with running such high amps and the welds come out nicely. But at the same time, I will be lying to you if I don't put my cards on the table and give you a little bit of, I don't know if I should be saying this because it seems a bit awfully personal, but I'm on price work. I get paid once the work is complete. This one piece of pipe here is worth around £400, and I'm doing nearly 200 inches a day fabricating and welding, earning nearly £3,500 to £4,000 a week. I have a interest in working as fast as possible and cutting what corners can be cut to maintain quality, but also get the money out the boss's pocket to put it into my pocket.
So the big bottles, we run out of big bottles, so we've only got these small bottles, and I never realized I'd run out of gas mid-weld. I'd run out of gas at this spot here, so it's all cloudy inside. I'm not happy with that, but the root is all the way in. It's just cloudy, and then there's a root all the way in this one here, and then even a root all the way in the socket too. You can see that outside. Let me put this down. It looks dark, but it's not that dark. But it's definitely not the best. It's not the best color. Here would be like the best looking part, but hey, it's done. What can I say? It's done. I had a little blow through there, but I fixed it. Sorted. Now, if you look at the drawing, that's obviously this part here. Yes, that's this part here. In theory, I could have done the whole pipe together, like I was saying, and flipped it over. There's no real reason to roll this out now, other than I don't know why I did it. I just thought I'd do it. Maybe because of the socket, I wanted these. I don't know, but there's no reason why I shouldn't have just done it all in one go. And that's what I'm going to do now. Tack up the last piece. Or the last pieces.
So that was a close call. These little bottles, BOC had run out of the big ones for some reason, so we ordered like nearly 60, 70 of these little bottles. And They was three of these little bottles was fitting into one of the you know, the full size BOC bottles. So if your eye wasn't watching the gas every second, you'd have something on the gauge, and within 3 minutes, 2 minutes, gone, empty, run out of gas. And that's what happened there. I change maybe 3-4 bottles a day between the argon and the nitrogen. It is annoying, and I'm always, you know, paranoid looking over. And this time here, it did catch me out, but it weren't too bad.
Anytime you've got a gap like this, you just have to hit it with a hammer. Gap closed.
All of the pipes I do, I pretty much tack all in one go, and it has been proven that it is the fastest way to do these. We're in a fab shop. We can flip every pipe. There really isn't a pipe that we can't flip, and if we want to flip, we could make it in a way to flip. So hold your horses a little bit with the comments when it comes to the fact that everything's being welded in one go, because it is literally a piece of cake welding it all in one go. When I do it, I do two varieties, depends on how loose my neck is. One, I start from one side and I go down as low as possible, and I can't comfortably start from underneath the pipe, and then I weld the one half, and then I go onto the other side and I just casually weld just a quarter, you know, from halfway to the top. That means when I flip it the second time around, all I need to do is just one little quarter. What I find, in order to get the tie-ins at the bottom, you need to break your neck so much, and with this big welding mask that I use, I really have to break my neck, and it hurts by the time I get home. So going down as low as possible and comfortably starting as low as possible is a lot easier, and then it's just the smallest piece to finish at the end. And then again, the other method that I do is pretty much that, but instead of one side starting as low as possible, I start both sides as comfortably low as possible, and just tie in. But I don't like that way too often, because your tie-ins, the welds that you're left with, it's really short. It's just a couple of inches of weld either side. At least with, you know, when you do one side all the way at the bottom and then the other side at a quarter, you've only got a quarter left to weld. It's a mouthful to explain, but you lot would know. Tying in welds at the very bottom of the pipe is it's a killer. It is a real killer. Now I'm ready to put the sockets on. 2 1/2-inch 15mm sockets. Pretty easy. Drill the hole, tack one side, use a square to square it off. Yeah, it's not really much to explain. When I'm welding the sockets though, they do want full penetration, so the technique that I've learned to get full pen on these sockets is a decently high amps, around 80 or so, 83 amps, and focus your heat basically on the pipe and then wash it onto the socket. You ain't gonna be able to have such a high heat that you're melting the socket without blowing a hole in the pipe. So focus on the pipe and wash it onto the socket. Now I save all the cleaning on all the joints until this point here. You know, I rag and use a grinder, you know, to get rid of the burrs from the saw. But at this point here, I go around all of it and I just give it a once over with a 3M radial bristle brush. That's a mouthful.
Purge bung.
Okay, there was 2 things that happened at this point. One, I forgot to put the purging bung on the inside of the elbow from the elbow side, so I could easily reach it from the flange side, so I didn't have to purge too much of this 10-inch pipe, but I forgot to put that in. And 2, my matey came in who doesn't want to be on camera, so he came in, so I had to blur out his face, and he comes in later on quite a few times knowing that I'm filming. He don't want to be on camera. He comes in and made a hard editing job for me. Now joining the 2 pieces together, it's a piece of cake, not hard at all. Again, because it's TruBore, all gaps need to be closed, so you're relying a lot on your fit up as well as the cut on the saw. So in the case of this, the level of the face of the elbow, meaning from the top to the bottom, you can't adjust. It has to butt up tight to the pipe. So I only have to worry about making sure the flange that I'm touching now is level to the T with the level on it, and then just tack it all together. Again, I could stand it upwards and then check the level of it, but there is nothing I could do if it's pissed. So
purge all of the whole pipe if I don't have to. The diffuser. Now I can put this flange on without worrying. Had I put this flange on earlier, this would be so heavy and just keep rotating around, and I'll have to bring out another V-stand that I don't have. So now I can put this on. Pipe's not going nowhere. So my battery just died, but here, it's all tacked up now, ready to be fully welded. All the ends are, all the gap where nitrogen can escape is taped up. But you see what I'm saying? So essentially, all of this, what I just did here, was not needed because I'm about to do all of these in position. So I could have added these into the position as well. So those of you who think what I should have done, for example, was roll this T and then join it onto here, and then roll these and then roll this and join it on, that isn't faster. I basically double handled with this here right now. So I'm gonna weld it up and I'll show you the end results. The first half is done. You see how low I start, so there's not really much that needs to be done on the other side. So the welds are coming out. But this, I think this one here looks the best, to be honest. And now I have to somehow flip it over.
So the welds came out okay. Again, nothing special. I don't ever try to say that I'm a brilliant welder. I've only been doing this for a short amount of time, and that's always been split between on the stainless and then back to the carbon shop. So at any given point, I've only done a couple months in the stainless fab shop. So yeah, the welding's okay, and I can say that because we've had a few guys come through the doors. Oh my gosh, let me tell you, some of the whole nonsense that they be producing, and they've been around the world welding. It just blows my mind. So I don't think anyone can get on me when it comes to this welding like this. And remember, guys, this isn't Schedule 10 pipe. Yeah, this is TruBore. It's a different board game. If my welds was looking all dark and ugly on Schedule pipe, then you can say something. But on this 2mm thick pipe, it's a different story. But this is what I was saying. So one side was started all the way down as comfortably low as possible, and I just have 1/4 left to do. Simple as that. Again, it's so it doesn't pull. My matey next door, he does it, comfortably from, let's say, 9 o'clock to 12, and then from 3 o'clock to 12. I'm sure it don't pull, but does it? Can I guarantee it won't? Who knows? Jeez.
Yeah, happy days, it's finished now. It is finished. The roots are in all the way around. Some of them are a bit dirty, but this is only for cold water. It's only for cold water. It is not an issue. But yeah, it's finished. It is finished. And the time is, I started at 8 o'clock. Time is 12 on the dot. So 4 hours work. Turning this into this.